All right, this is Algebra 1B, Part 1, Unit 5, Lesson 8, the Unit 5 test, Part 1. You're receiving this video because you have some points to recover on the Unit 5 test, Part 1. What you need to do is go to your gradebook, click on the score that you received for the test. That'll open the test with any feedback and score, and you'll be able to see the score. Jot down the problem numbers for any problem that you did not receive full points on, and then come back to this video, get out a sheet of paper and a pen or a pencil, and write down everything I write for the problems that you missed. Make sure to write down everything that I write down. Don't just write down answers. And then take a picture of your work and send it attached to a webmail or by text, and you will receive up to half your points missed back, which is rather significant, so it'll make a big difference in your grade. So without further ado, question number 1. You're given a quadratic equation, negative 2x squared plus 7x plus 15. And I will note, by the way, this is not the exact problem on the test. All the problems have been changed to protect the security of the test itself, but they will deal with the same concepts. So you're given a quadratic equation, negative 2x squared plus 7x plus 15 equals 0. And you're given some x values to try out, negative 5, negative 3/2, 1/2, to see which is a valid solution. And the way you find out if it's a valid solution is you substitute. So x equals negative 5, plug in negative 5 for x right here and right here. Negative 5 and negative 5. Everything else stays the same. So this is negative 2x squared plus 7x plus 15 equals 0. Negative 5 times negative 5, which is negative 5 squared. Negative times negative is positive. Negative 5 times negative 5 is positive 10. So exponents first. Then multiply. Negative 2 times 10, and negative times a positive is a negative, negative 20. Negative 7 times, 7 times negative 5 is negative 35. 35, negative 20, and negative 35 is negative 55. Remember, if they're the same sign, you end up adding. If they're different signs, you end up subtracting. And already I can see that negative 55 plus 15 is not 0. It is negative 40, which is not 0, so that is not a solution. So then we try another. Let's go try negative 3/2. So negative 3/2 and negative 3/2. Okay. There we go. Negative 2 times negative 3/2 squared plus 7x, or negative 3/2 plus 15. Wherever you see an x, you put a negative 3/2. And notice I insert or substitute with parentheses. That's really important. So, and this is negative 3/2, not positive 3/2. Negative 3/2 squared means negative 3/2 times negative 3/2, and negative times a negative is a positive. When you multiply fractions, you multiply straight across. So 3 times 3 is 9. 2 times 2 is 4. So this is 9/4. Okay, multiply straight across. So think of this as 2 over 1. Negative times positive is negative. 2 times 9 is 18, but I'm going to do a little cross reducing. 2 over 4 reduces to 1/2. So this results in negative 9/2. Okay, positive times negative is negative. Negative 7 times negative 3 is negative 21/2 plus 15. Negative 9/2 and negative 21/2 is negative 30/2 plus 15. Negative 30 divided by 2 is negative 15. And negative 15 plus 15 is 0. So negative 3/2 is a solution. Now, we'd like to say we can stop. But one of the things we discover is that with quadratics, they often have two solutions, so we need to try the 1/2 as well. So let's try 1/2 instead. Let's put this over here. 1/2 squared. I'm going to take the squared off. I can put that in a little later. 1/2 n for x. Everything else stays the same. Okay, so we're going to write -2x squared plus 7x plus 15 equals 0. 1/2 times 1/2 is 1/4. Two times 1/4 reduced to 1/2, -1/2. 7 times 1/2 is 7/2. Plus 15. 7/2 and -1/2 is 6/2. 6/2 is 3. 3 plus 15 is definitely not 0, it's 18. So that is not a solution. So x is -3/2 is a solution. It's not necessarily the only solution, but it is a solution of the quadratic equation. Okay, number 2 is asking about a general concept. If you have a squared number, like x squared equals, and on the right side you have a negative number, what is the rule concerning that situation? And here's the idea. And let's make it a perfect square here, -9. You might think, well, it's 3. Well, 3 squared equals 3 times 3, which is 9, not -9. Well, you might think it's -3. -3 squared means -3 times -3, which is +9 again. There is no solution. Okay, so the rule is if a squared equals a negative, there is no solution. Okay, if a squared equals 0, there is one solution, 0 times 0. Right? That is one solution. So there is one solution in this case, if the right side is 0. If the right side is positive, as in the case of +9, then we can, as we see, have -3 or +3 squared equaling 9. There are two solutions. There are two solutions if the squared equals a positive number. And we would say x equals plus or minus 3, positive or -3. Okay, number 3 is asking us to solve this equation by inspection. In other words, by thinking about it. Here's the way I think about it. 3 to the 6th is the same as 3 to the 2 times, or to the 3 times 2. And using the power of powers rule, I think this is 3 to the 3rd squared. So it's quite clear from this point that x must equal 3 to the 3rd, because x squared equals 3 to the 3rd squared. If for the exponential expressions to be equivalent, their bases must be equivalent if their exponents are equivalent. So x equals 3 to the 3rd, or 3 times 3 times 3, or 3 times 3 is 9, 9 times 3 is 27. Okay, but actually the answer on this we need to focus on is 3 to the 3rd. Number 3. Right, question number 4. We're going to solve this quadratic. We're going to use a method of undoing. Imagine, if you will, peeling an onion. You peel the outside layer of the onion first, and then the next layer, and the next layer, and the next layer, getting down to the inner core, the interior of the onion. The interior of the onion is an X. We're peeling off the outside layers and getting down to the x. Another way to think of it is like a dog pile. In football, when the ball is fumbled, everybody piles on top. Who has to get off the pile first? The last one on. So the way I think of it is this. PEMDAS would order that I would take x, subtract 4, then square, then add -10, then divide -13. The opposite of the last thing I just said is multiply -13. So that's what I'm going to do. I'm going to multiply both sides by -13. Let me move things around here a little bit and make a little room. I'm going to multiply both sides by -13 because it's the opposite of divide -13. So we're going to multiply both sides by -13. The -13, the multiply and the divide are being opposites, cancel each other out. -10 plus x minus 4 squared equals negative times negative is positive, 26. Now, think of it in terms of opposites and backwards. So x minus 4 squared plus -10. Opposite of plus -10 is minus -10. Minus a negative is plus. Minus a negative is plus. So really what I'm doing is I'm adding 10 to both sides. Anything you do to one side, you do to the other. So we end up with -10 plus 10 is 0, so that basically cancels out. X minus 4, quantity squared, equals 36. Now we peel off the next outside layer. X minus 4 squared. Opposite of squared is square root. So we square root both sides, but when we square root both sides, we've got to remember the rule that says plus or minus. There are two roots, two square roots, a positive and a negative. And what number multiplied by itself makes 36? The answer is 6. So x minus 4 equals -6 or positive 6. Plus or minus, both positive and negative, two solutions. And now we're going to peel off the minus 4, getting down to the kernel of the x in the interior. Add 4 to both solutions. So x equals -6 plus 4 is -2, and our 6 plus 4 is 10. So our solution set is -2 or 10. We would give it as a solution set in curly braces, -2 or 10, like that. All right. Okay, number 5. Number 5 says, evaluate or find the values of x that make the following equation equal to 0. We're going to use something called the zero product property. Zero product means multiply, property. What it says is if we have two numbers multiplied together that equal 0, one or both of the following must be true. Either a equals 0 or b equals 0. That's the only way for this to happen. Either one is 0 or both is 0, or one or the other is 0 or both are 0. So this means we can write x plus 5 equals 0, or x minus 3 equals 0, and solve both equations. Add 5 or subtract 5 from both sides of this equation, and add 3 to both sides of this equation. Okay, we end up with x equals -5, or x equals 3, right? And that's the way they give the solution. Now, they use the word and. That's a little misleading because and implies that both can be true at the same time. They're not. So it really should be or. X equals -5 or x equals 3. Okay. All right, number 6. Solve the factored quadratic equation. Again, we're going to use the zero product property. which says if two things multiply to be 0, one or both of them must be 0. If A times B is 0, that is only because either A equals 0 or B equals 0, or both. So we have this multiplied by this equals 0, so either 15x plus 2 equals 0, or 8 plus x equals 0. Solve both equations and you have your solution. Subtract 2 from both sides of this equation. Subtract 8 from both sides of this equation. Note that this one, unlike the previous one, takes a little bit more work. So we get 15x equals negative 2, or x equals negative 8. Then we're going to divide by 15. Okay, on this one here, so that x equals negative 2/15. So the solution set is negative 8, negative 2/15. Number 7. Solve the quadratic equation by factoring out the GCF. That's the greatest common factor. In this particular case, you'll notice there's no constant term. So both terms have an x, and that suggests I can factor out an x. What's not as clear is what else I can factor out. Now you might check and see if 8 divides evenly into 96. 96 divided by 8 goes once, 1 left over, 12. So 8 times 12 is 96. You could also do the prime factorization and pull out any prime factors. But in this case, I'm just going to do it this way. I'm going to factor 8 out. I'm going to factor x out, because I know 8 goes into both 96 and 8, and then at x is in both 96 and 8. And so now I think 96x squared divided by 8x. That is 8 times 12 is 96. X times x is x squared. And canceling with an 8 and with an x, that leaves 12x. Okay, or you can think 2 minus 1 is 1 for the exponent. 96 divided by 8 is 12. Okay, 8x factors out of 8x. All that's left is 1. And now use the zero product property. That is that either 8x equals 0 or 12x plus 1 equals 0. In the first case, divide by 8. In the second case, subtract 1 from both sides. In the first case, 0 divided by 8 is 0. In the second case, 12x equals negative 1, 12x. The opposite of times 12 is divide 12. So x equals negative 1/12. Okay. And again, my disagreement with this is x equals 0 or x equals negative 1/12. We really shouldn't use the word and, because that would imply they can both be true at the same time, and they cannot. Okay, number 8. Which of the following quadratic equations is not solvable by grouping? You may recall, or you may not, but you may recall that if you take the first coefficient, 1, and multiply it by the last constant, negative 70, that the middle term should subtract in this case to make 9. The middle term should subtract to make 9. Now 1 times 70 is 70. So things that multiply to make 70 are 1 times 70, 2 times 35, 3 doesn't go, 4 doesn't go, 5 goes once, 20, 14 times, 6 doesn't go, 7 times 10, and I think that's about it. Now which one of these has a difference of 9? 70 minus 1 is 69. 35 minus 2 is 33. 14 minus 5 is 9. And so there it is. And 10 minus 7 is 3. So we can take 9x as the middle term, or 9 as 14 minus 5. Now we want negative 9, so we want negative 14 and positive 5 to make a negative 9. So it would look like this. X squared minus 14x, okay, plus 5x minus 70 equals 0. And then you would group and factor. We're not going to do that because it didn't ask for that. But this one works. This one works. Let's check the next one here. Take the first term, 2, and the last term, 15, and multiply them together. 2 times 15 is 30. 30 is 1 times 30, 2 times 15, 3 times 10, 4, no, 5 times 6. Do any of those add up to 30? Add up to 30. 1 and 30, 2 and 15, 2 times 15 is 30. 2 and 15, 2 plus 15 makes 17. So 1 plus 30 equals 31. 2 plus 15 equals 17. 3 plus 10 equals 13. And 5 plus 6 equals 11. So none of them equal 30. So this one is not possible. Okay, and I'm going to go ahead and stop there. I'm going to leave the last one off here because I can. Right, hopefully we've explained the process enough. Multiply the first by the last and to get a product, and the middle term should add if it's plus on the last term or subtract if it's minus on the last term to make the middle term. Okay. All right, question number 9. Question number 9 showed two solutions to two quadratic equations. Asked you to determine which one was correct and which one was incorrect. The first one was one like the first question I've asked here, x squared plus 5x minus 36 equals 0. Okay, in this case, we can do this a couple of ways. We can do it by grouping, or we can do it by evaluation. I'm going to do it by grouping just to remind us how to do that. Take the coefficients, 1 and 36, and multiply them. And list the factors. 1 times 36, 2 times 15, 18, 3 times 12, 4 times 9, 5, 6 times 6, and that's about it. Which of these has a difference of 5? A difference of 5. 36 minus 1 is 35. 18 minus 2 is 16. 12 minus 3 is 9. 9 minus 4 right here. 9 minus 4 is 5. So this is the same as x squared plus 9x minus 4x minus 36 equals 0. 36. Make sure that looks like a 3. 36 equals 0. So I'm going to factor out an x out of the first two. So this is x plus 9. I'm going to factor out a negative 4 out of the second two. Negative 4, x minus 4 times 9. And negative times negative is positive, so positive 9. Note that there is an x plus 9 in both, so this is x plus 9 times x minus 4. I'm going to factor out an x plus 9, x minus 4. With just by evaluating, by thinking about it, you can actually come up with the factors just like this in a single step. Okay, at this point, either x plus 9 equals 0 or x minus 4 equals 0. So subtract 9 from both sides. x equals negative 9, or add 4 to both sides, x equals positive 4. So negative 9 or positive 4. Notice those are the opposites of these two numbers. Okay, the next one here was a little different in that, and this is where the trick was, or where the catch was, or the tripwire. Oops, wrong one. Try that again. The tripwire was in the fact that it didn't equal 0. It equals 10. In order to solve by factoring or by grouping, you need to get it in standard form. You need to get everything to the left side. So start by subtracting 10 from both sides. If you don't do that, you're not going to get the right answer here. So x squared minus 6x plus 7 equals 0. Now think, 1 times 7 is 7. Factors of 7 are 1 and 7. That's really it. We need factors that add to. Oh, wait a minute. Careful. Careful here. We got a problem. This one has no solution. I need to change the problem here. I need this to be a negative 7. So I'm changing the problem, because otherwise there's no solution. Okay, so I'm going to change this to a minus 17 and this to a negative 10. Minus 17. So that there is a solution here. Minus 17. Okay, so now add 10 to both sides. We get x squared minus 6x minus 7 equals 0. And now that it equals 0, we can solve by factoring. 1 times 7 is 7, and that's really about it. And that has a difference of 6 if we make the 1 positive and the 6 negative. So we're going to do x plus 1 and x minus 6. Notice how in this method I just go straight to the factor. I don't do all the grouping and stuff in between. Okay, and so either x plus 1 equals 0 or x minus 6 equals 0. Subtract 1 from both sides, x equals negative 1, or add 6 to both sides, and x equals 6. So x equals negative 1, or x equals 6. Again, I much prefer the word or between those rather than and. X can't equal two things at once. It's only going to equal them one at a time, either one or the other.